Okay, so let's start. Hi everyone, thanks for coming. So I'm welcoming you for the next session that will be related to overcoming the frontier. So let me start from introduction of myself. My name is Azet, and I'm a proud father. I have two sons. I'm also a solution architect and working for EPAM systems. My primary programming language is Java, and recently I started to interested in artificial intelligence and how we can solve business problems by applying artificial intelligence. I'm also passionate about agile, clean code, DevOps, and other good practices that are helping us to deliver good software. So that's about me. Let's go to what we are going to talk about today. So I believe most of you are working on the challenging and pretty interesting projects. However, I doubt that everybody had a chance to participate in really huge, really unique in terms of scale, in terms of complexity, and in terms of solutions that were built to deliver it. And I had this chance. I participated in one of these projects, and today I'm going to share with you some insights, some unusual practices, unusual solutions that our team was invented or introduced for the project in order to keep it in a, let's say, good shape and to make it delivered. There will be also some takeaways and some useful links for you if you're interested to check out after the talk. Some kind of disclaimer, it's not about just me, it's about the team, because team was the main driver. Without the team, there were no such solutions, there were no such practices would be introduced to the project. And sorry, this talk will be without code. Usually I do some demo with some coding because of small talk and because of some NDA, so I cannot share many things with you. And I believe it will be a surprise for you, the same as it was for me when I joined the project, because there are lots of unusual things that we as a project had to do in order to deliver it. And that will be your takeaway. So all this talk will be related to these practices and solutions that were introduced. So let me start with some overview of the program. That program was built 30 years ago. There is a business critical application that is running across hundreds of stores across a whole country, relatively huge country. And it was built on top of IBM S400 and DB2 as a storage. And the interesting fact that most of our requirements were reverse engineered from the source code, and we had more than 6 million lines of source code in the legacy system. Why that? Because there were no documentation, there were no any architectural description. So there were just some subject matter experts who kind of understand some part of the application, how it works, but there were no holistic vision of what application does and why it does this way. So as for the new platform, it was built based on the Java and Spring framework as a backend. However, we have kind of one main requirement is like for like from user experience, from user interface, to eliminate necessity to reteach employees, to retrain them to do the daily activities. So they keep them in the same place, in the same behavior as they already have. And in order to achieve this, the new custom UI engine or framework was developed in order to emulate the green screen. Green screen means terminal, right, where there is black background and green text fields. So there is no mouse, just a keyboard with many functional keys and many hotkeys and so on. And all these things is working inside the modern web browser like Chrome, Edge, and so on. So we had to do this. And there were lots of time, talents, and really, really hard work in order to achieve this. And it's, like, as it usually with any customer, they want the best quality, right? And for the cheapest price. And our customer is not an exception from this rule. And in order to achieve this, there were lots of practices introduced, and I will share with you some of them. So let's start with so-called gentleman's kit. At least I'm calling it as it is, because this kind of the common or basic setup that each project should have. I mean, continuous integration, continuous delivery as part of tools that we are using for this is GitLab, Jenkins, SonarQube, Artifactory, Ansible. So I believe most of you know about those tools, and I won't concentrate on them. We have also automated tests and the peer code review. So basically, all good practices that most of the teams are doing. So it's okay. But unfortunately, that was not enough for our project. And we were struggling with many things related to code quality, number of bugs, coverage of the tests of our functionality by unit tests, by acceptance tests, so many challenges. And one more challenge is the application by itself, right? And the main requirement, like for like, because there is no requirements, there is no any chance to get, let's say, to one screen of our application to perform some steps, test cases, right, that we usually have in order to verify some functionality. And test cases built based on the requirements, but in our case, we had no requirement, and every screen, every functionality should be validated based on comparison of the legacy application and the new application. So in order to move forward, screen-to-screen testing was introduced. It was designed to verify this like-for-likeness of application. Basically, the idea was to leverage acceptance tests to add some additional, it doesn't work here, to add some additional layer of dedicated runners. One runner will do regular in-browser testing, and one more runner will do in-terminal testing. So basically, we pick here the terminal proxy, made some changes, and this was helpful in order to do this interaction with the legacy applications through the terminal. Then we have, instead of verification of the steps, we have just print screen of after each test of the screen in the browser and screen in the legacy application, and then collecting them in Artifactory, and then we have a comparator. And basically, a comparator did this comparison of like for like. So we have screen from after some action from legacy application and screen after some action in the new application. We can div them, right, and then compare whether this functionality working correctly as expected. So is it like for like or no? Also, this tool compares text reports, because this system is producing lots of different reports in text formats. So this tool was also helpful there. Unfortunately, that was not enough, and team had to introduce one more testing approach, which is calling DB to DB, or database to database comparison. Why this? Because of the necessity to verify many jobs. We have more than 400 jobs, background jobs. Some of them are doing a lot of database modifications. And unfortunately, with screen-to-screen comparison, we cannot verify this part of functionality. So database is helpful here. In order to do this, we have this kind of steps to perform. We are starting from the snapshot 0, where we have dump of the legacy system. Based on this dump through ETL, we are creating snapshot 0 to be deployed for our new application. And then we do exactly the same operations in two systems, like running some jobs in legacy and running exactly the same jobs in the new application. Then they're doing their work, modification of tables. And then we have one more dump from the legacy application, ETL it, and then import it to the MariaDB. And then we have capabilities to compare the states of the tables inside our database. And as part of those jobs, our interest in more than 100 of tables after these operations. So we need to compare those more than 100 tables to verify that functionality is working correctly. So it's pretty huge work and pretty fun, let's say. Okay, of course, our stores, right, they're operating not just for one day, so there is many life cycles, many reports, and many dedicated activities that should be performed within the store in order to, let's say, create a sales report for the day, sales report for the week, sales report for the month, and so on. So we have to simulate these activities in order to verify that after each this kind of milestone, our application is still working and behaves as expected. Okay, I believe at this point you already get some recognition that by introduction of such amount of testing, probably we have lots of bugs, right? And that's actually true. After some time, our bugs was just was exponentially growing, and customers started to have concerns regarding the quality of our product. And they even brought to some external audit to verify that we are doing right engineering practices, that we are doing some that we are writing tests, that we have CI/CD and so on. And in order to prove them that we're actually doing a good job, we introduced several more tools to help us to improve our quality of the code. So first thing is Facebook Infer. That's a relatively new tool, which is static code analyzer, which helped us to kill lots of potential null pointer exceptions, resource leaks, and many other things. Unfortunately, it is slow and it cannot be integrated into regular CI/CD pipeline, but to run it regularly, let's say once a day or something like this, in order to verify that there is nothing new arrived related to null pointer exception and so on, it will be really useful. So it helped us a lot. And one more practice that was also introduced is mutation testing. As I said, there were concerns regarding the quality of our testing, and by introduction of mutation testing, we were able to prove that our tests are not so bad. Mutation testing, for those who don't know, is just a tool which introduces mutation to your code and then runs your tests. If test fails, that means that this mutation is killed, and it means that your test is behaving as expected and it's correct test. If test passed, right, after mutation, that means that there is a question what your test is doing because it didn't fail. So this thing helped us to prove that because of the margin between coverage without mutation testing and coverage with mutation testing, there was a margin about 10%, and most of the complex modules were kind of covered with good amount of tests, and this margin was not so big. And for sure, we found some issues, and we spent a lot of time to improve other modules with testing. Okay, let's move forward. There is one more tool that was invented as part of this project. As you know already, we have a legacy application with data, and each store has a unique set of data. And in order to make sure that by importing this data to the new application, we should have some guarantees that it will work. And in order to do this, not to fail in production, we would like to have some proactive capabilities to verify the state of the database. And database validator was introduced. Basically, it does validation of all enums that we have. It does validation of column constraints, of referential integrity, because the legacy application, there is no SQL. Literally, there is no SQL. There are just flat files, and all data is stored in these flat files. In our case, we have relational database, and we need to kind of guarantee some relations between the tables. At least our GPA layer expects those relations. So that was also helpful to us. And there is one more tool that was introduced again for testing. There are lots of testing in our project because there are lots of screens. We have more than 15,000 screens in our application. And I believe you understand that it's really hard to write such amount of scenarios by hand in order to cover all these screens with some logic on the screens. So the new testing tool was introduced. We call it Spider. The idea is pretty simple of it. Basically, it does navigation through the application, and due to the fact that we have kind of limited space of possible actions that user can do with application, we are able to implement it automatically. So basically, it goes to some screen, analyzes what this screen has, what possible actions, what it can select, what it can input, and then does it automatically. And there is just one scenario and lots of code to achieve this. But at the end, it can navigate through all our screens and to find bugs during the navigation, during the transition between screens and different logic. Okay, that was it about testing, and there are some helpfulness from machine learning that we have. As you already know, we have lots of bugs. There was a huge turnover of new bugs, of fixed bugs, and reopened bugs, and so on. And we were thinking of how we can accelerate bug fixing. And one of the possible ways is to accelerate it through proper assignments or through optimal assignments when we, let's say, group several bugs which are close together in terms of root cause of those bugs and assign them to one developer so that this developer will fix them step by step sequentially, and which means that this developer won't switch context between bugs. And in theory, it will do fixes much more quickly. And with such amount of bugs that we have, to do it manually, it's almost impossible. We tried, but we failed. And there was an idea to try to apply machine learning. And we did clusterization of bugs. So basically, we extracted from Jira all bugs that we have. We digitized them, passed through TF-IDF algorithm, which provides ways of the words inside the bug and then inside across the whole bugs, and then pass through automatic clusterization, affinity propagation algorithm, and then as a result we have lots of clusters with bugs grouped by similarity of description. And as part of description, we have summary, we have description, labels, and comments for the bugs. And based on this, we have this set of clusters. And finally, this was helpful for the team leads to assign kind of groups of bugs to particular person for the fixes. One more thing where machine learning was also helpful, exactly with the same approach, but a different application. So we have huge regression suite. There are more than 17,000 of test cases, and it is really, really slow. And with more time, it slows down even more. And in order to fix this thing, to have fast regression, we thought we have to refactor our regression and to shrink it a bit. And again, machine learning was helpful here. So basically, we extracted the log execution of our regression, digitize them, pass through ML algorithms, and the result, we had several, like at this diagram, we have those dots are actually clusters of tests that are pretty similar. And for some cases, as you can see here, there are more than 200 tests, about 200 tests per 2 clusters, which means that they really do the same. So we need to fix this. And one more potential application of artificial intelligence. It's just a POC for the moment, but from my perspective, it's really interesting because it opens a lot of opportunities for us. That's extension of our Spider, but with introduction of artificial intelligence agent and introduction of OpenAI gym environment. So basically, the idea is to control our Spider navigator tool by artificial intelligence agent, and based on the feedback through the gym environment, the artificial intelligence agent should learn what sequences of actions Spider should perform in order to achieve some results, and those results can be encoded in the reward function, because here we're leveraging reinforcement learning. We basically have agent, we have environment, and agent interacts with environment, gets some feedback. If feedback is positive, that agent should do these actions more. If feedback is negative, it should forget about these actions. And based on our POC, there is some capabilities to implement this and to apply for the real applications. There are some references that I was talking about through the presentation regarding mutation testing, Facebook Infer, soft-actor critic paper that's regarding the artificial intelligence agent, and affinity propagation is clusterization algorithm that we were used to this clustering. And one more key points of this algorithm is that it doesn't require from us to specify how many clusters we would like to have. It does it automatically. Some takeaways. So as an engineers, we shouldn't believe in like-for-like requirement. We have to challenge them and to find the true reason behind those requirements. And as part of the solutions that we were talking about through the presentation, I believe you got that. I believe you also know this. There is no constraint and there is no predefined set of practices that should work or could work on your project, so you can expand them and to introduce something new that will work and will help you with your delivery. And we need to think out of the box and act as a team, because only when we have a good team, we can achieve the great results. So there is almost 2 minutes for questions, if there are some. So I'm happy to answer. Yep.
I missed what static analysis tool did you use in the beginning, but why you choose FB Infer but not SonarCube?
We used it, but it was not enough. So basically, FB Infer works on top of SonarCube.
Okay, thank you.
Thanks.
Could you describe a bit about the approach of estimation of such a project, and whether it was time and materials or fixed price, what it was?
I won't be able to tell you in 50 minutes or 50 seconds that we have. So, sorry. Any more questions?
A small question. If you work with SonarCube and FB Infer, what would you say would have been the difference between the two?
So both are, yeah, thanks for the question. Both are great tools and we use them both, but they do slightly different things. SonarCube is kind of an aggregator and executor of different tools, and now they're kind of introducing more and more own rules. But still, the level of depth that they are doing from static analysis point of view is not enough, and FB Infer does a bit deeper analysis, and it finds really good evidence of potential issues like null pointers, resource leaks, memory leaks, concurrency issues. So they do lots of analysis of the source code, much more deeper than SonarQube. Yeah, that's why they're slow. Yeah, thanks. Anyone? So we have finished our time. Okay, thanks for coming. I hope it was useful for you. So, thank you.